correct? The control, this is the IE. We know this is same as here. In case of SCR, you have anode, you have a cathode and gate. Gate can be considered as a base, equivalent to a base in a transistor. Equivalent to, I am saying. It is not exactly same, but there is a structurally different. Again, you can see that there are two transistors connected in this configuration. Please note that you are going to see not transistor, but it all packed inside. They are fabricated as a single device. That is this. Correct? This is cut section view of SCR for understanding purpose. This is called as 4-layer device. 4-layer, correct? Silicon device. We know that transistor is a 3-layer device. Correct? For example, NPN, collector, emitter, and base. And diode is a 2-layer device. PN. And this block represents a transistor. Correct? So this is single layer or single junction. One junction is there. This is a 3-layer or 2 junctions. And this is a 4-layer device. SCR is called a 4-layer device. It has one P material, one part, immediately succeeded by N material, followed by P and N. PN together. They are stacked, they are fabricated a single device. So this is the J1 junction. This is J2 junction. This is J3 junction. In case of transistor, you have J2 and J1. In case of diode, you have a J1. So that's why this is called a 4-layer device. So we correct. You can see that I can bifurcate this figure. I took it from internet. It's not I have drawn, but took it a nice figure to understand. So from this one, this can be transistor 1 and transistor 2. Please note that actually it is one device only. For understanding, it is separated. The N part, this N part is divided in 2 parts. This P part also divided in 2 parts. So one become one transistor, PNP. This is a transistor 1. This transistor, correct? P followed by N, middle this is correct. This is my emitter. So it forms one transistor. Correct. This I can call an emitter. This is a base. Please everything this not SCR. Take 2. I cannot say this is a SCR. You have to 4-layer device. That's how it works. Please, then we can see that out of 4 layers, layer we are connecting a wire that is called anode. The last part in the P, this is P region, we connect one to pin or bring out one wire. We say gate. So gate is equivalent to a transistor base. Okay, that means I give input signal to control the current flowing through this. Right? So we are going to see that. So that's why you can see that if I give a input called a gate pulse, correct? It has to be supplied with a voltage, correct? I supply a normally it is 0 volts. This is voltage 0 volt for a short duration, maybe microsecond. The manufacturer says 5 volts or 10 volts, whatever the voltage, or 20 or 100, depending upon power rating. And if you give a or 10 milliseconds, generally in the order of microseconds, sometimes maybe milliseconds. Correct? If I give, then current will start flowing from and will flow. So what bias the SCR also? How to bias? SCR should be biased like a transistor. Anode should be connected with the positive of the DC voltage source. Cathode should be connected negative. Okay. So this is plus, this is minus. This is, I say, VAC. VAC means voltage across anode and cathode. In case of transistor, we say VCE. Voltage across collector and emitter. Here we say VAC. Correct? Where cathode. Then you need to give another voltage, but not constant voltage, as a pulse between cathode and gate. You have to give a pulse. This is called as gate trigger pulse. You have to supply gate trigger pulse. You give a pulse. Okay, as I told you, you supply, first you have to supply voltage between anode. We say VAC, but like VCC, correct? We say VAC also, the manufacturers. What is voltage you can give across anode and cathode? Say 50 volts, I don't know, even it can be 30, depending on power rating. 30 volts or 50 volt, 100 or 500. There are SCRs which can work even 5000, 2000 volts, right? Voltage can be given between this. Voltage can be anything like this, depending on the manufacturer says. Then they say, what is gate voltage? Gate pulse. Gate pulse also VG. What is this? They say 5 volts or 10 volts, correct? Or 50 volts or 100 volts. They will say gate pulse, correct? But it cannot be DC. Generally, a pulse will be given. And the duration also, the gate pulse duration, microseconds or nanoseconds, they will say. No, basically, by biasing the SCR with a DC voltage as given by the manufacturer, we say VAC, that is anode and cathode, plus minus. Anode should be connected with plus, cathode should be connected with minus. We connect, there will be a current. There will have no current flow. Okay. So you connected, for example, for this SCR, the manufacturer, this voltage is 100 volts. Okay. I have taken a battery or power supply, DC power supply. I connected 100 volts across this. Now, once you connect, there has to be current flow. The current we call as IA. I can say that IAC. It is volt. It is not voltage. It is current. So we have to say I. Some books they put IA, anode current. Some book IAC, anode to cathode current. Don't get confused. Similarly, this voltage they say VA. Some books put VA, anode current, anode voltage, or VAC, anode voltage, anode and cathode. They are called bias voltage. So then this current will be zero. Even though you applied 100 volts across anode and cathode, current flow will not happen. We know that in transistor also, you connect VCC, correct? Plus minus VCC. I say that this is 30 volts. This is collector. This is emitter. It is a NPN transistor. You already biased. Whether current IC will flow? No. IC will be zero as long as IB is zero. If IB is zero, base current is zero, that means you need to connect a voltage. We say VBB, correct? Base voltage plus minus for NPN transistor. If this voltage is zero, IB equal to zero, even though you apply 30 volts, the IC will be zero. Okay. If I want to make this current, I have to pass IB should be greater than 0 amps. Correct? We got base current. So that depends on voltage. That means only when supply a base current, which is greater than 0, IC will flow. Correct? IC will flow. If IC flows, then we say transistor is conducting. Correct? We say transistor is conducting only when IC is flowing. When is IC is flowing? Only when base current IB is greater than 0. 0 amps, I can micron, million, that depend upon what is the IB you have to supply the manufacturer data sheet say. Similarly, in case of SCR, we need to supply between anode and cathode, there's a voltage. What is the rated voltage? Correct? Like VCC max, for this also, they give VAC max in case of SCR. This is in case of transistor. You are given this voltage is 100 volts. You are given. Now, IAC, that means current from anode to cathode from the battery will be 0. Correct? Current won't flow till you give a gate pulse. VG you have to supply. Only when you give a gate pulse, immediately current start flowing. Okay. That's what we will. Please take down the symbols, all those things. Let me go to the next slide. Okay. How the silicon transistor works is shown here. Please note that this is the SCR. This is the symbol. Already we know that. This is called as voltage current characteristics. Voltage versus current characteristics of SCR. Okay, this is called voltage current. So you can see that x-axis we are applying voltage. So you can see that this is origin 0. X-axis this side is, you can see a positive V. This is VA, correct? VAC positive. This is 0 volts. Left side is negative VAC, which is we are applying across this one. You can reverse also. Between anode and cathode, give a positive voltage, negative voltage. If the given positive voltage, anode is positive and cathode is negative, then the SCR is forward biased. SCR is forward biased. Just like transistor, correct? We know that NPN transistor collector should be positive with respect to emitter. VCC we are supplying. So this is called a forward bias condition. That means this is a forward voltage. Please note that the VAC here is varied from 0 to maximum voltage, correct? So this is called a breakdown, VAC max, which is also called a breakdown voltage in SCR. Okay, so the voltage can be 0 volts, 10 volts, 20 volts, say 30, 40. This transistor, the maximum voltage VAC, they say Vmax equal to 40 volts, which is called a breakdown voltage. Okay. Now, I told you, in case of SCR, I connected a battery. The DC voltage, positive to anode, cathode is negative, and this voltage varied from increasing, correct? In the x-axis, you can see here, I am increasing from x-axis. I am drawing an arrow, 0, 10, like that, I am increasing. This is called a variable. 0 to 40 volt I can give, correct? So I am increasing 0 volts, 5 volts, 10 volts, like this, I am increasing. As I increase this one, current will be 0. You can see that the y-axis is nothing but anode current. This is IAC. Current flowing from anode to cathode to power supply. When it will flow, that is called, I call as IAC. Correct? So here they put just IE, that is anode to cathode. So as I am increasing voltage from 0 volts, you can see that anode current is very small. Very small current will be going. You can see that this is called very leakage current. Leakage current will be in the order of milliamp something. Theoretically, it should be 0. Theoretically, before the breakdown voltage for this SCR manufacture 40 volts. That is the VAC max, which is called that says that as long as the voltage applied between anode and cathode, I'm increasing 10 volt, 30, all those things. The IAC, the current flowing from anode to cathode, will be almost theoretically it should be 0. Practically in the order of milliamps or microamps. Correct? This amplitude. But you can see that once my voltage reaches VAC max, which is now a breakdown voltage, even without applying gate pulse. Please see that what I am showing here is, I will clear this. Here I am increasing voltage, 0 volts, 10 volts, 20, 30, this is 40. But I have not given, I have supplied only the anode to cathode voltage, VAC alone. Gate I have not given, VG equal to 0. I have not given anything. But even then, if voltage, the applied voltage by anode cathode reaches 40 volts, automatically current will start flowing. That is called breakdown voltage. That's why it's called breakdown voltage. You should never apply the voltage to between anode and cathode to the VAC max or breakdown voltage. You should always supply lesser than. If you want to control the SCR properly, then you should apply voltage lesser than the maximum voltage or breakdown voltage. But that means for this transistor, the SCR, you need to supply maximum 35 volts. 40 is breakdown. So 0 to 35 volts only you can apply as a voltage like a VAC or anode voltage. Okay. Now, that is one thing. That means you should not apply. Now that I applied 35 volts, I apply 35 volts between this and this. Plus, minus, sorry, this is minus, I given 35 volts. Okay. That means less than 0.1, the current will not go. The SCR is not conducting. Why? The current is not flowing. Because my voltage of anode cathode is this one. So now, if I want to do this one, what I have to do? After this, I give you a pulse. Correct? I give you a voltage pulse at the gate. I supply. I say, for example, 100 microsecond duration. The voltage is 10 volts. The pulse height should be the SCR data. She says, what is the VG you need to supply? Correct? So if they say 10 volt pulse for 100 microsecond, that means you have to supply here. Once the pulse is given, then current start flowing. Then VAC equal to 35 volts. IAC, anode to cathode, was 0 amps, as long as IG equal to 0. When that means VG equal to 0. I have not supplied any voltage. I just supplied anode cathode voltage, that they get the SCR will not conduct. And after some time, I say that this is what the timing diagram. Correct? I say this is VAC. VAC I have given 35 volts. This is 0 volts. This is plus 35 volts. I am given. Now this is my VG gate voltage. Now I have given, if I see that the current will be 0. Correct? I can draw here. The current will be 0. Correct? This is IG. IAC. IAC is 0. Correct? Then what I do is I give a pulse, gate pulse, when after some time. For example, this is 0. You can see that this is time axis. Correct? All are time. This is 0. Correct? Starting. And after say 1 second. Correct? After 1 second, this time is 1 second. I gave 100 microsecond 10 volt pulse. That's what the manufacturer said. Once I give, you will see that immediately the current in this one will start flowing. This is my IAC. You can see that up to this, the current was 0 amps. Once I gave the pulse, after 1 second, immediately the current will start flowing from here to here. Okay? Please note that I gave the pulse only for 100 microsecond. After that, my IG has become 0. But still, the SCR will be conducting. It won't stop. Once you give a trigger pulse at the gate of the appropriate voltage, appropriate time, the anode to cathode current start flowing. We say that this is called a SCR conducting. SCR is conducting only when the current from anode to cathode is flowing through the battery power supply. Current is start flowing. You can't stop it. Once the SCR start conducting, you please see that the gate pulse green color for 100 microsecond only I gave. After that, it becomes 0. Correct? This is 0. Voltage is 0. So even then, the SCR is still conducting. How long it will conduct? Till you stop the voltage like this. Unless you kill this voltage, which anode to cathode voltage, what you apply, this should be stopped. Only when this becomes 0 volts, the conduction current will stop. IAC will become 0. I will say that SCR will stop conducting. This is one of the important characteristics of SCR. SCR won't conduct on its own. Conduction means you apply a forward bias voltage across anode and cathode as given by the manufacturer, whether 30 volt, 100 volt, and 2000 volts or 5000 volts, depending on this one. Then, if you are not given the gate pulse, then the IAC will be 0. That means my SCR is not conducting. If I want to make my SCR to conduct, I have to give a gate pulse and appropriate time when I want to. So that's why it is called as silicon controlled rectifier. Right, we'll see how it can use it. So if you give a pulse, immediately then it start conducting. So this property can be used to control the rectifier. So the SCR can be used as a AC to DC converter. We call it like diode. We can use it as a convert the AC voltage into a pulsating DC voltage. So that means it is like a diode. You can use this SCR as a diode to convert the AC voltage to DC voltage. Why? Only when anode cathode is positive, the SCR will conduct. Only during positive half cycle, SCR will start conducting. I am going to show that. That is one thing. Now, this is called a forward bias area. Okay. So there are different regions are mentioned in which you can see the blue color, what is the current flow, correct? Voltage is in x-axis, y-axis is the current flow. In forward bias condition, if I give the appropriate voltage and give a trigger pulse, the SCR can be made to conduct at any voltage. At 10 volts also, 20 volts, 30 volts, any voltage you can make it conduct. But if you apply voltage more than the breakdown voltage, even without gate pulse, SCR will start conducting. Then SCR is no use. Correct?
Sir,
Apply.
Sir, I have a question over here. Can
Yes,
I ask?
please. Definitely.
Sir, one thing that you have taught us is that in NPN type of transistor,
Yeah.
okay, or
Hmm.
PNP, whatever. Suppose IC is to be like positive or some meaningful number, then IB has to be positive, right?
In NPN.
NPN or
PNP is reverse.
PNP,
Voltage
right?
is reverse.
Okay. Yeah. So basically, exactly, sir. So basically, if we have base current positive, then only we'll have IC.
Yes.
Right, na, sir?
Yes.
So
Correct.
suppose at the time t0 we have applied IB is equal to 5 ampere for time being,
Okay.
and at t is equal to 10 seconds we like cut off the IB.
Immediately
That
transistor
time-
stop. That is beauty of the
Exactly.
transistor.
So exactly, sir. So now in this condition, like silicon control rectifier that you have taught us,
Yes.
even if we make gate current 0 after a
Yes.
certain time,
It
still
will,
it
once
is
you start conducting, you can't stop.
So what is the physics like difference between these two configuration that makes it what I mean to say is
See, it is
continuous
connected back to back, no? You can see that the collector of the one transistor is connected to base. Again, the collector other transistor is connected back to back. So they start conducting. Once conducting, they start conducting because you are applying voltage. This is not needed. Back to back connection. That's why there are two transistors which allows, because the collector current, this is the IC, no? Of this one. This is the IC of this transistor. This is given as a base. This is given as another base. So once you given the base current, then one time gate Wilson, it start conducting. Both transistors start conducting. They don't need external as long as the power is supplying.
Got it, sir. Got it. Thank you, sir.
Okay. Now, if you want to stop it, you have to cut down this voltage.
Got it.
Only when make this voltage equal to 0.
So IC becomes like a base current for the both transistor in that sense,
yes.
right?
No, it goes to one transistor, but the other base current is circulating. It is circulating. Connection back to back connection.
Noted, sir. Thank you.
Okay. So that means the stopping the SCR is possible only by making anode to cathode voltage equal to 0. That means you have to really stop it. Correct? Once it's conducting. Before conducting, it will wait till you give the gate pulse. Otherwise, that's why it's called controlled rectifier. Okay. How it can be used rectifier, we can see it next. Okay. So this is called a forward bias region. In the reverse bias region, you can see that again, this is 0 volts, this is minus 10 volts, and this is minus 20, minus 30, minus 40. Correct? Here I said plus 10, plus 20, plus 30, plus 40. Correct? So this is 40. So you should not apply. Reverse also, it will like again, you can see the as increase the negative voltage. At particular this one, the current will start flowing from this direction, from cathode to anode, because you are given negative voltage here from positive here. They call reverse plus minus. They call reverse bias. This region. That also, when the voltage exceeds beyond the what voltage manufacturer supply, current will. So generally we don't use it. This region is called as blocking region. Correct? Reverse blocking region. That means anode is negative, cathode is positive. Correct? That time SCR will not conduct. Again, you can see the current is negative current. This is negative current. It is almost 0. Theoretically, this should be 0, but practically microamps are going. But once the voltage reaches the minus 40 volts, for example, or plus 40 in this one, breakdown happens. Both sides breakdown happens. Correct? So that means you should operate only if the manufacturer says you buy a SCR, they say the breakdown voltage is 40 volts. You should operate lesser than 40. Right, both directions are this one. Okay, this is called the reverse bias direction. Because of these two properties, positive reverse bias and forward bias, we are able to use the SCR similar to a diode as a rectifier. We will see that. Okay, so that is one thing. Now, for normal operation, to make the SCR is a 4-layer device. It has three, this one kind of pins. One is called anode pin, other one is cathode. The third pin is gate pin. Gate pin is called as a control pin. Anode and cathode should be biased through the load. We are going to see how we can do that. Okay, that's one thing. Now, when we talk about SCR, already there are the modes, they say modes of SCR working. Okay, already explained for understanding. One is called forward blocked mode. Note down, these are important. Exam, you are expected to write all this thing. Forward blocked mode. First operation. In that case, what should be condition? Anode is positive voltage, and the cathode is negative. Okay, and the gate voltage is 0. VG equal to 0. So this I say VAC is, for example, 35 volts. Please note the cathode will automatically 0. With respect to this only, we are giving 35 volts. Anode is given 0 volts. Cathode is given 0 volts. Anode is given 35 volts. That's what the manufacturer says. Gate voltage you are supplying 0. Correct? You are not giving any. So you are given like this. In this case, what happens is the junctions. There are 3 junctions. Correct? There are 3 junctions. 1 minute. Let me. Okay. So this I call this as J1. Second junction between the P and N. This I call the J2 second junction. Then this we call as J3 junction. There are 3 junctions. In this, the junctions, right? The junctions J1 and J3 are forward biased. If you give like this, if you give anode equal to positive volts, what is the allowed volt? 35 volts, cathode is 0 volts, and gate VG is 0, then we say that the SCR is in forward blocked mode. Blocked means stopped. Why we say block? Even though we are given positive volt anode cathode, IAC will be 0. Why? My VG is 0. Please know that J1 is forward bias, J3 is forward bias after 3 junctions. 2 junctions are forward bias. Still, J2 is reverse bias. Correct? J2 junction is reverse bias. Reverse bias or no current supply. That is nothing but gate, which is forming the gate. You can see that this junction is blocked when VG equal to 0. That is called as forward blocked condition. Correct? Voltage is anode voltage, the gate you are not given. So IAC will be 0. So I say that my SCR is not conducting. SCR is not conducting. That's why it is called a forward blocked mode. It is ready for conduction. Anode to cathode current is ready to flow, but gate you are not given. You are not given permission. So this condition is called a forward blocked condition. Okay. Then next, take this because I will going to delete this, again write something else. The second mode, shall I? Okay. The second condition is called as forward conduction mode. In forward conduction mode, anode is positive again. For example, 35 volts. Cathode is 0 volts. Is negative, that is 0 volts. And what we are doing is, in this case, supply gate terminal with VG, a positive voltage, for example, 10 volts. That means IG will flow. Please note that by giving voltage, you have to make current to flow, like IB. IB is the base voltage. You here, IG is the base current, gate current. IG should be greater than 0 amps. So that means if you are given 5 volt, 10 volt, like what manufacturer, immediately IG will be positive. Once this one is, the IAC will flow. Now, this is called a forward conducting mode. This is second mode of operation, second step. Now, once IAC start flowing, because I gave a IG gate pulse, not continuous voltage, I have to give a small duration, microsecond, millisecond, with a voltage, for example, 10 volt pulse. This is my VG, correct? But between anode cathode, you are supplying continuous voltage. That should not be stopped. 35 volts is always applied. In forward blocked condition or forward conducting condition, the anode is applied for 35 volts, cathode is 0 volts. But once I give the gate pulse, Vg equal 10 volts as per 100 microsecond duration like this, as suggested by an figure, immediately Ig will start flowing. For example, that you need to control. You have to put like RB register. Here we put RG, gate current control resistor in SCR. But for the understanding, Ig is flowing. Correct? Some 10, say 1 amps or 500 milliamps, something is flowing depending on this. So immediately IA will start flowing. Correct? And IA, for example, IA depending upon load condition, IA start flowing. This is called a forward conducting mode. Most important thing is once the SCR enters into forward conducting mode, you can see here it was blocked up to this is called blocked region. Correct? And I gave pulse immediate at this time. Immediately you can see the current start increase, steep rise. So it goes to your maximum current. This is for example 10 amps. Right? The supply, this is IESC become 10 amps. It will start flowing. It won't stop. Even though my gate voltage becomes 0. Correct? That's why it's called forward conducting mode. You can't stop the conduction of SCR. Only way to stop is reverse the voltage or make VAC equal to 0. Stop conduction. Stop conduction is VAC should be made 0. That is only way. Or switch off the power between anode and cathode. That is why you can stop it. Otherwise, no other way. Okay. That is the one condition. The third condition is called as blocked condition. Blocked mode. Condition or blocked mode. Okay. Forward blocked mode. Then forward conducting mode. We can say that reverse blocked condition or reverse blocked mode. You can say that. The third mode is called a reverse blocked mode. In that case, what I do? I supply a negative voltage to the anode and this is my VAC. VAC, positive is supplied to cathode, negative is connected to anode, and basically it is not going to, that is we are talking of this region. Already anode positive is negative, so it won't conduct. During this condition, even if you give you a pulse, VG, and the conduction will not happen. Even if you give the pulse, when anode is negative, cathode is positive, which is called as reverse bias condition or reverse blocked mode. Even if you give a gate pulse, 10 volt pulse for any amount, the SCR will not conduct. So this region is non-conducting. Correct? They can reverse bias. These are 3 modes you have to understand. Okay. Now, next thing what we are going to see is same figure only what I shown in the previous this one. This is for a particular SCR. For particular SCR, forward breakdown voltage I said 40 volts. Correct? If you give automatically even without, once the VAC is equal to 40 volts, which I say the breakdown voltage, this voltage. Correct? I am increasing voltage 0, 35, 40, even without gate pulse. VG is 0. Still IAC will flow. That is called, you can see that it goes, suddenly you can see the current start increasing. Correct? So even in the forward condition, even without gate pulse, SCR will conduct. When the voltage across anode to cathode is equal to or above the block voltage, breakover voltage or max voltage. So you should never bias your voltage across anode cathode close to breakover voltage or forward breakdown voltage or also forward maximum voltage. You should never apply. You should always operate like this. This is one thing. Here what we are saying is the SCR voltage current, same thing only what I shown in this one. Again, blocked condition, forward conduction condition, this is IAC, this is VAC. You can see that for different IG, correct? So I can supply IG equal to 0. IG equal to, for example, 1 amps. This IG equal to 2 amps. Correct? This IG equal to 3 amps. By giving different IG, correct, I can make the conduction stop at even lesser forward voltage. This is 0 volts. This is, for example, 10 volts. This is 20 volts. This is 30 volts. This is 40 volts. Correct? I told you, I applied here only 20 volts. Correct? But if I give a gate pulse, again, it will conduct. What I want to say is, as long as the VAC is positive, correct, less than the breakdown voltage, I give trigger pulse, it will start conducting immediately. That's what we are saying. For different the gate currents, please note that IG is gate current, that is because of VG. Because of VG, IG is flowing, correct? The VG can be different voltage, correct? 10 volts, 5 volts, correct? You can give different. If you give different voltage, I said 10 volts, you can give 15 volts or 20 volts, 30 volts. Higher the voltage, more current will go in the gate, and so the conduction will start early, even with less anode to cathode voltage, correct? For even lesser positive forward blocking voltage, if I apply higher gate current, the conduction start. That's what this one slide shows you. Okay. Okay. Then how to use my SCR as a half-wave rectifier? That's what we are talking here. Already we say half-wave rectifier using a diode, one diode. Here for conducting the only thing is here I can control the conduction angle. So the V average voltage or VDC from the SCR based half-wave rectifier can be controlled by varying what you call firing angle. Okay. I will just quickly explain so that you can understand. You can see that this is the AC voltage, correct? I say 220 volts. This SCR can withstand, they say VAC, correct? They say maximum voltage is 220. Actually, literally speaking, the peak voltage, V peak. What is V peak? Any idea? I say that this voltage called VRMS voltage. Correct? 220 volt RMS, so 440 RMS. VP. We saw this one. Anybody?
Root 2, sir.
Root 2 times VRMS VP. If I there, then you have to multiply 1.414 multiplied by 220. That should be the VAC max of this one. If I am supplying this one, VAC max should be around 310 or 320 volt. Correct? So this voltage is 330 volts or 310, whatever may be. Similar negative 330. Okay, so this is what you apply. You can see that this voltage is similar to what the diode rectifier, half-wave rectifier. Now, please note that during this cycle, which is called as positive cycle, anode is positive, cathode is negative. Correct? From here to up to pi, this is 180 degree positive cycle. It is going, but if I don't give these pulses, correct? This is positive. This is called forward blocked condition. Correct? It is called forward blocked condition. This is reverse blocked condition. So one cycle, correct? This one reverse blocked condition. Correct? In both the condition, my SCR will not conduct. IAC, this is IAC. Please note that I have connected a lamp, electric lamp as a load. Electric lamp as load is RL. For example, this is 10 ohms. A bulb, incandescent bulb. I connected in series with my AC voltage, connect to SCR. Right? Now, the bulb, this IL is within nothing but IAC will be 0 as long as I don't give these pulses. I supplied voltages. Correct? Anode is doing positive half cycle. My anode is positive. Cathode is negative, which is called forward blocked mode. Correct? If I don't give the gate pulse, the SCR will not conduct. Reverse condition, automatically you know that even if you give the pulse, it won't work. So that means my output voltage will be 0. Current will be 0. Correct? Load current will be 0. Okay. Now, if I wanted to make my bulb to glow, what I have to give? During the positive half cycle, this is my positive half cycle. During this one, somewhere I have to give a pulse. What I did, I am giving a pulse. You can see here, this is pulse. The time I will make it red color, you will see it. So this duration, after this duration, please note that this is a half cycle. This is another half cycle. Generally, when we talk a sinusoidal, we talk about 360 degree. This is 180 degree. Positive half cycle, 0 to 180 degree. During 0 to 180 degree, after, for example, this is 60 degree. Correct? After 60 degree, I gave a pulse to VG. This is my VG pulse. So IG is flowing. You can see that immediately, this is the load voltage, V this one. this was 0 as long as it's a blocked condition. After 60 degree, correct, with respect to time you can convert later. In case this one, you can see that immediately SCR start conducting, correct? So the current is flowing. So this is the positive half cycle. And the negative half cycle, we are not given this one gate pulse. Even if you give your gate pulse, will it work? No, because my anode is negative, correct? Cathode is positive. They call a reverse bias condition or reverse block condition. During the time, even if you give a gate pulse, it will not work. That's why they call a half-wave rectifier. Similar to diode rectifier. Only one thing is why it is called silicon controlled rectifier. What I can do is I can give different angle. Correct? I can give different. Instead of here, if I give you a pulse here, gate pulse here, after, for example, 100 degree, correct? For 0 to 100 degree, VG is 0. After that, I give this pulse, not here. Then what will happen? My diode will start, my SCR will start conducting this region only. Again, this region only. Correct? Again, this region only. You can see that it is lesser than what is. So, if I find the average voltage for different conduction angle, then V average or VDC will be lesser. That's why this is called as silicon controlled rectifier. Correct? I am controlling angle of conduction. This is called an angular conduction. I can give pulse here, I can give pulse here, or I can give pulse here, I can give pulse here. Accordingly, my SCR will conduct. So take down this formula for conducting. You can say V average, correct? Because of the high load going to will be varying by varying the conduction angle, where I am giving my gate pulse with respect to 0 to 180 degree. Within 180 degree, I can give my gate pulse anywhere. So accordingly, conduction of the current flowing through varies. So take down the formula. This is the final formula. Correct? So, for example, you will be asked an exam, simple problem. Draw the SCR based half-wave rectifier, show this working using these waveforms, and also compute what will be V average voltage when alpha is called as conduction angle. Correct? So this is called as alpha. Here, for example, I told you 60 degree. It can be pulse can be given here 100 degree. Pulse can be given something here 150 degree. Not only beyond 120, because half-wave rectifier. Correct? So I say that V average equal to, if I vary the conduction cos, correct? This will be vary from 0 to 180, you can vary. If you vary, this voltage will vary. Correct? So this is how half-wave rectifier works. Okay, take down this formula and the graphs and this one. So again, when we call about rectification ratio, we also talked in case of a diode also. Rectification efficiency, this was nothing but PDC supplied this one divided by PLRMS, which can be computed using this for note down this formula. Correct? In the exam, half-wave SCR rectifier given alpha. Alpha is varied 30 degree, 60 degree, 120 degree. Compute the VAC for different alpha. Correct? In the exam, for example, I say it cannot more than 180 for half-wave rectifier. Then every time you have to substitute this pi equal to 180. Correct? This equal to will vary 30, 60, 120 like that. Again, same thing. Wherever alpha is there, you will vary that. In the exam, you ask 2 or 3 values. Compute the rectification efficiency. Compute the V average or VDC. Correct? Then you have to use this formula. Correct? Again, last one is find out RMS value of the load output voltage. Correct? We say that VRMS of load. Note down this formula you have to use. So this, I don't want this derivation. This formula should be noted down. You'll be asked to find out RMS value of load output voltage, VRMS load equal to VM divided by 2 into root pi into root of pi minus alpha plus 1 divided by sine 2 alpha. Alpha is called conduction angle. Correct? So you are asked to vary the conduction angle 60, 30, 120, 60, 120, 3 value, 4 value, something. Find out this value, find out this, and also find out this. Maybe as per this, or note down this. Okay. So that's it. That is called as half-wave rectifier. Okay. So again, The formula is given here for other. How will you find out current? This is for finding the voltage, correct? DC voltage coming out of the half-wave rectifier. This is called as equivalent circuit control. This is conduction. We have seen that. This is to find out VAC, and this is to find IAV, average load. I can say IL, correct, which is nothing but load current. So again, same for only what you are seeing additionally here, divided by, see, this is same Vmax divided by 1 plus cos alpha. This is nothing but V average divided by RL, correct? IL equal to V average divided by RL. So the RL is in denominator. Note down these two formulae. Already the same formula only. This formula only, correct? We have written here also. Take down the formula. Okay. That's one thing. Okay. Next thing is, so this is half-wave rectifier. That means you will be able to control positive half cycle only by varying conduction angle. You can change the output voltage coming from this one supplied to load. This is called supply load voltage. Load voltage can be varied by varying the conduction angle alpha. But in case of diode rectifier, no. Positive half cycle will conduct. For example, diode rectifier, I gave you like this. This is half-wave rectifier, right? We know. This is my load resistor. Positive half cycle alone, it will conduct. So what will be the output voltage? It will be pulsating DC. Correct? So diode will conduct, you cannot. But in case of SCR, by giving a pulse, I can make the SCR to conduct a particular angle only. So here it is not conducting. So my V average is controllable. In case of SCR half-wave rectifier, in case of V average of diode rectifier is not controllable. Half-wave will control. So here, by varying the conduction angle, I can vary the V average as per this formula. So I can vary the load current, load voltage. So I can vary the speed of the motor. Correct? Speed of the motor of the, for example, AC induction motor, AC synchronous motor, your vehicle, electric vehicle you are using, I will use SCR instead of using diode. If I use the SCR, I can control the voltage, average voltage, because our average current is varying. We know that the torque motor is proportional to IL. IL is nothing but IAV. That this is IAV is varied by varying the conduction angle. Correct? For given load is fixed. Your Vmax is fixed, AC voltage given is fixed, you are varying alpha, varying 0 to 180, I can make V average equal to 0 to V average max as per series. So because of this, I can conduct my AC motor very nicely used by controlling the conduction angle of the gate pulse. When you are giving the gate pulse can be varied. That's how your vehicle controller is doing. If you press the accelerator pedal, what it does, it sends the gate pulse different location, somewhere like so. So the average voltage is varying. Any doubt? If you understand this, very simple. Okay. Similar to that, we like diode rectifier. This is SCR bridge rectifier. This is called a full wave rectifier. If I want to control both the positive and negative, also control the conduction angle by varying this one. Instead of using we saw D1, D2, D4, D3. This is diode rectifier. Instead of that, what I replace? I tell thyristor. T1 means thyristor. This is not a SCR. Correct? Instead of diode, bridge rectifier, I replace with 4 SCRs. And for 4 SCR, I have to give VG1, VG2, this is VG3, VG2, and VG4. Please note the AC voltage is given. Similar to diode bridge rectifier, this is my load resistor, which can be motor or a light or any other electrical load which want DC voltage. AC is the input voltage. This is the DC voltage, is the output voltage. This is my rectifier. So again, similar to that, I can conduct both positive and negative half cycle. So bridge rectifier for input, you can see that this is positive half cycle, this is negative half cycle. This is positive half cycle, this is my negative half cycle. So this is positive cycle, this is negative cycle. This is positive cycle, this is negative cycle. Right? So I can control the angle. This is by controlling, by giving this one, you are able to control the rectification angle. So the amount of VDC, V naught is nothing but VDC. VDC can be controlled. So the current also controlled. So I'll be able to use both the half cycle. Both cycles are used. Similar to diode rectifier. Okay, understand? Any questions? For this bridge rectifier, the output voltage, you can just take out this V naught is nothing but VDC. Take down this formula, correct? So the final, so this is the formula for V naught equal to VDC or V average. Same as V naught is now 1 divided by pi into alpha, where alpha is the conduction angle, pi into Vm to sin omega d omega, which can be finally, if you substitute upper and lower limits, you will get VDC equal to Vm by pi into 1 plus alpha. This is the final. Correct? So how will you compute the current flowing IL or IDC or I average or sometimes they are I naught? Is nothing but this voltage divided by RL. This is RL. So you can say again, note down the formula. Correct? This is the final formula for VDC. I naught equal to this is the final formula. Then how will you compute the power supplied by this using this formula? Correct? P supplied by SCR bridge rectifier. P of the power is IRM square multiplied by RL load. Note the formula. How will you compute IRMS? IRMS is this is the formula. Correct? So you can note down this formula. There are two ways. P equal to IRMS multiplied by VRMS. One formula. In that case, you need these two. Take down this formula. Exam, you can expect problems. What I will give is, I will ask you to draw this bridge rectifier and with waveform, show that how it works, explain. Okay. Then compute the V naught or VDC for different conduction. Alpha equal to say 40 degrees and alpha equal to 80 degrees. Compute V naught, I naught and power for the bridge SCR rectifier. Then you need to remember this formula. Okay. I think time up. With this, we have come across power this rectifying devices. One is diodes and other one is SCRs. Okay. Sir, later, when we talk about controller, we will talk about controlling DC motor, how to control DC motor using SCR. In the next class, we will discuss. And also, we are going to see tomorrow what you call a MOSFETs. MOSFETs, as called, we are used for as a power device, control device, controlling motors. Basically, we will talk about FET and also MOSFET. After that, we will see IGBT. Tomorrow, we will talk about MOSFET. After that, we'll talk about IGBT. With this power devices used for controlling AC motor, DC motor, power amp devices, we will complete. Next week, we'll start about batteries. Correct? Energy storing devices. We are going to talk. Sir? After that, we will talking about how to find the different this one sizing the motor and engines for a given hybrid vehicle, right? So torque calculation, power calculation, how it works, all this we are going to see 8 to 10 classes. And I wanted to complete this by this week. Tomorrow we have 1 hour. Day after tomorrow, Wednesday, we have 1 hour. Thursday, we are going to have 5 to 7. No more postponement. There will be a class 5 to 7. Otherwise, sure, exam is coming. So I want to have this week 5 hours, 1 hour over. Tomorrow, 6 to 7. Wednesday, 6 to 7. Thursday, 5 to 7. Okay. So this week we'll have 5 classes. Next week also same. Because already you missed 4 classes. All those things should be compensated. Otherwise, we will not be able to cover the portion. See you tomorrow by 6 o'clock. Please give your attendance as a chat message. Good night. Yes, please.
Sir, you were told before midsem that you are going to give the notes or whatever the PPT you prepared, sir, for our preparation. Great to send to us.
Because the slides I consider, but the slides are no, because it is like a scribbling pad, no? This whatever I type, you can see, I will show that. You can show that all these things. Yeah. This looks like scribble. Do you want this?
Yes, sir. That would be helpful, sir, if it is there.
Okay, I will send this, convert as a PDF and send it to you, okay?
Sure, sir. Sure. Thank you.
I'm
Thank you,
saving
sir.
whatever
Sir,
I am doing, actually I'm saving this, I can send it to you, and so that it will be useful for your inside preparation.
Sure, sir. Thank you,
Thank
sir.
you.
And
So,
one more.
Yeah,
Yeah, Chidambaram, go ahead.
Chidambaram, please.
Give the assignment, sir, so that we can like complete that activity.
Yeah, assignment I will give you after another week.
Okay, sir. Okay, sure.
Because assignment will be given after the last, almost close to last class, 10 questions, maybe problems, all those things. And you are given 1 week time for preparation. That time you prepare your assignment also, which will be useful for your exam also. Assignment will be given just before 1 or 2 classes before the last class. And because your exam is, you have 1 week time, no? That time you prepare the assignment, that will be preparation for your exam also. Generally, that's how you do
Sure,
it.
sir. The only reason is like 2 exams are like we have another exam also, so the students will get more time. It means
Okay,
if
I
we
can give 1
complete
week
that.
before also, no problem. 1 week before
Sure.
also I will give you.
Okay, sir. Sure.
Within another, see, this week, end of the next Friday. Next Friday, not this Friday, next Friday, I will
Okay.
give the assignment.
Sure, sir. Sure.
Okay.
Thank you.